Hello and welcome to our notes on 3B4, atomic number and mass number. Hello and welcome to our class notes on atomic number and mass number. This is 3B4. To understand atomic number and mass number, we have to first take a look at what particles are found inside an atom. We've already learned that inside the nucleus of an atom, we have the positive protons and we have the neutral neutrons. These are the larger two of the three subatomic particles. Protons and neutrons are large when compared to the third atomic particle, electrons. Both of these particles are found inside the nucleus of the atom. The nucleus atom is an incredibly dense inside of the atom, and it takes up very, very small space overall. The proton and neutron are also called nucleons. Nucleons are any particles inside the nucleus. In terms of chemical reactions, protons and neutrons are not directly involved. The particle that is directly involved in electrons is the negative particle, or chemical reactions is the negative particle, which we call an electron. Electrons are not found in the nucleus, but instead they orbit in three-dimensional spaces, which we call electron clouds, outside of the nucleus. So electrons fly around at incredibly high speeds. Their path is three-dimensional, and they are the particle that is involved in chemical reactions. So those are the three subatomic particles that we're going to be discussing at this point. The reason we need to understand these three particles is the terms atomic number and mass number are ways of telling how many of the various particles we have. The first very important number that we're going to discuss is called the atomic number. It tells us the number of protons found inside the nucleus. Protons are positive. If an atom is neutral, in other words, it does not have a charge overall, and it's sometimes called normal, the number of positive things have to balance out with the number of negative things. If you have more electrons than protons, we would have an anion or a negative ion. If we have more protons than electrons, we would have a positive ion called a cation. So if an atom is neutral, that means there are an equal number of protons and electrons. So for neutral atoms, the atomic number will also tell you the number of electrons. The atomic number is abbreviated with the letter Z. And Moseley, a famous chemist, realized that the atomic number is important in determining the chemical identity of an atom. So if you know the number of protons, you know which atom we have, and you also know something about how that atom will behave chemically. Why is it that the number of protons identify what element an atom belongs to? In other words, we thought we just mentioned a few seconds ago that it's the electrons that are involved in chemical reactions. And that is true. But remember that the number of protons reveal the number of electrons for neutral or normal atoms. In chemical reactions, atoms can gain or lose electrons in a chemical bond called an ionic bond. So atoms can gain or lose electrons in chemical reactions. However, it does not change the identity of an atom. A chemical reaction does not result in different atoms than we started with. Only nuclear reactions involving the nucleus can change the number of protons or neutrons. Chemical reactions can involve changing the number of electrons. So, the reason we know that the number of protons is vital in determining which atom an element belongs to is because if an atom gains or loses electrons, it doesn't change the atom. Chemical reactions, whatever atoms go into a chemical reaction, must come out. Atoms that gain electrons in a chemical reaction form what we call a negative ion. Since electrons are negative, if you gain something negative, you end up with a negative charge. So gaining electrons results in a negative ion. We call that anion. Remember, anion has the N right in the middle of the word. That's the negative ion. It gained electrons. Atoms that have lost electrons, lost, you see the positive sign right at the end of the word lost. If you see a positive, ion, we know that it lost electrons, and those are called cations, the big positive sign right in the middle of the word. Another way of remembering that cations are positive is because cats have paws, so cations must be positive. As we just mentioned, chemical reactions involve electrons. Nuclear reactions involve the nucleus, which can change the identity of the atom. So in a nuclear reaction, atoms can gain protons or lose protons. Neutrons can also be involved in nuclear reactions, but if an atom gains or loses a neutron, it wouldn't change what atom it is because it's the protons that identify what atom an element belongs to. In Unit 3B, you will need to have a periodic table of elements handy because this Unit 3B really takes us into the periodic table of elements on an extended level for the first time. We're talking about atomic number of protons, and that's the number that identifies what atom an element belongs to. The only way you would know that is by looking at your periodic table of elements. A quick reminder, your periodic table of elements is found in the class information section on Google Classroom. So up here on this particular table, in the upper left-hand corner, they have the atomic number. Sometimes they write it above the element. Sometimes that number is written to the right in the upper right-hand corner. Sometimes that element is below the element. But this whole number that we see on the periodic table of elements is the atomic number. So hydrogen has a 1 in its box. That means hydrogen has 1 proton. And if you have an atomic number of 1, you have 1 proton. Any atom with an atomic number of 1 belongs to hydrogen. What is common between all atoms of hydrogen? They have 1 proton. If you have 2 protons, you belong to the helium atom. 3 protons would be lithium, 4 beryllium, etc., etc. Silver, a precious metal, is any element that has 47 protons, or an atomic number of 47. Gold, right down here, 79 protons. Any atom with 79 protons in the nucleus is gold. The other number that we see in these boxes right here is the 1.01, the 9.01, 12.01. In this phosphorus box, there's a 15 here and a 30.97 there. That's called the atomic mass. The atomic mass, as we'll learn later in Unit 3B, is the average mass of all the naturally occurring isotopes of the element. And we'll be talking about isotopes in just a moment. A second number that we need to be familiar with is called mass number. Mass number is the number of protons added to the number of neutrons for a particular isotope of an atom. And again, we'll mention isotope in just a second. Mass number gives you the number of nucleons. So if you want to know how many particles are in the nucleus, how many protons and neutrons there are, what you're wanting to know is the mass number. Once again, nucleons are the protons and neutrons in the nucleus. The mass number will generally always be bigger than the atomic number because the atomic number just gives us protons. The mass number gives you protons and neutrons. The only atom where the number of protons, the atomic number, is not necessarily bigger than the mass number is the element hydrogen, because many hydrogen atoms do not have any neutrons. So hydrogen could have an atomic number of 1 and a mass number of 1. Mass number is abbreviated with the letter A. If you remember, atomic number is abbreviated with the letter Z. We've been talking about isotopes, but we haven't really told you what they are yet. Isotopes are atoms of the same element that vary in number of neutrons. So what makes an atom a particular element? It's protons. Neutrons do not determine what element an atom belongs to. So an atom, as it turns out, can have different numbers of neutrons. For instance, there are 3 common isotopes of carbon. All the isotopes of carbon must have the same atomic number. In order to be carbon, you have to have 6 protons. So there's what we call a carbon 12. There's a carbon 13 and a carbon 14. The 12 and 13 and 14 are mass numbers. So 3 isotopes of carbon. There's a carbon-12, a carbon-13, and a carbon-14. By and large, the biggest percentage of carbon atoms have 12 particles in the nucleus. 6 protons and 6 neutrons add up to 12. Some carbons have 13 particles or nucleons in the nucleus. Once again, they would have to be 6 protons to be called carbon, which is represented by the C. And in this case, they would have 7 neutrons. Another carbon atom, a radioactive form of carbon, is called carbon-14. It has 6 protons plus 8 neutrons, so that 14 is the mass number. What makes these 3 atoms different? The number of neutrons. What do these 3 atoms have to have the same in common in order to call them carbon? They all have to have 6 protons. So these are 3 isotopes. Isotopes are atoms of the same element. What do they have exactly in common? 6 protons. Any carbon atom that has 6 neutrons is the carbon-12 nucleide or nuclide. Carbon-13 nucleides have 7 neutrons. Carbon-14 nucleides have 8 neutrons. What do we mean by the word nuclide? Nuclide is a distinct kind of atom where the nucleus is characterized by having a certain number of protons and certain number of neutrons. A nuclide has to have the same atomic number, and it would have to have the same mass number. So the mass number of the carbon-12 nucleide is 12, 6 protons, 6 neutrons. So what's really the difference between a nuclide and isotope? Isotopes are any atom with the same number of protons. A nuclide is same number of protons and same number of neutrons added together. I kind of look at it like this. A nuclide would be an identical twin. Identical twins are exactly the same. Isotopes are like fraternal twins. They are related, they're not exactly the same. So the 3 isotopes of carbon all have 6 protons, but they're not exactly the same. So nucleides would be like exactly the same, 6 protons and 6 neutrons. So once again, mass numbers. Mass numbers are numbers of protons and neutrons. How can we find the number of neutrons if we know the mass number and we know the atomic number? Well, this would not be too hard to do. The number of neutrons would be the mass number minus the atomic number. Mass number is protons plus neutrons. The abbreviation for neutrons is an N with a little zero because they're neutral. The abbreviation for protons is P with a positive sign because they're positive, and the abbreviation for electrons is E with a minus since electrons are minus. So to find the number of neutrons, if we take the mass number, which is protons plus neutrons, and subtract off the atomic number, which is just protons, we would have protons plus neutrons minus protons. What happens if we have protons plus neutrons minus protons? We would be left with just neutrons. A second ago, we were talking about carbon-12, carbon-13, and carbon-14. When you write a symbol with the mass number after it, you're expressing that element in what is called hyphen notation. Hyphen notation shows the symbol followed by the mass number. It could also be the name followed by the mass number. So they could write this out in a longer form. Carbon, the word carbon, C-A-R-B-O-N, hyphen 12. Now, when you use hyphen notation, they're expecting that you have a periodic table with you. So all they're telling you is the mass number. Why? They assume that you have a periodic table to look up carbon's atomic number, such as this table right here. We see carbon's atomic number is 6. So anytime you're using hyphen notation, you would have to have a periodic table handy. In our next video, we will learn another way to represent information regarding a particular atom. We learned to represent it right now using hyphen notation. In our next video, we'll learn nuclear symbol format.